Trying to get an edge on your political rival? Simply take a guess at how public opinion will change. There is obvious value to being able to make predictions on the shifts of the political climate. For example, applications in marketing, campaigning, lobbying, and more. This sounds like a task for machine learning. Surprisingly, there are no models that predict conservative versus liberal sentiment out the box. The goal of this video will be to create our own model, Polybird. First, we needed an initial dataset to train our model on. I combed through every option, and unfortunately this kind of dataset just didn't exist for Twitter. This meant we were effectively on our own. We either had to create a new labeled dataset or find a similar one. I started off with a base model and made sure to install all my packages. The model I chose as my base was Distillbird. A lightweight transformer-based model suited the classification tasks like conservative versus liberal. The model was trained on a Reddit dataset that I found on Kaggle.com. I figured the model would translate well from Reddit data to Twitter, considering the similar content. There would be some conflict, however, with our Reddit dataset due to Twitter's use of short-form content and hashtags. Luckily, this issue was easily resolved with further training. Because my dataset came from Kaggle, it was likely reliable, as authors tend to clean and balance their datasets before publishing to the platform. You can find the dataset I used for base training down below. I didn't factor this in when planning our project, but our dataset had a labeling imbalance of 65% liberal, 35% conservative. This bias could potentially throw off our model. Our first model was trained on a 75% training, 25% testing data split, saving a quarter of the labeled data for evaluating our performance. After training on the Reddit dataset, let's load up our very first model and get our evaluation metrics. Our first model has a rather high evaluation loss of 1.12, a low accuracy of 12.6%, a low precision of 36.6%, a low recall of 10.1%, and a very low F1 score, resting at just 14%. This model isn't great, but that's okay. Our goal was to give the model a base understanding of political terms. Let's test our new model, trained only on Reddit data. Taking example phrases we can easily distinguish is a good way to test. Take, for example, the phrase, "My dog died yesterday." This is a politically neutral statement. Sad, yes, but not inherently conservative or liberal. Using phrases like these, let's test our model. Here, we can see our model gets one prediction correct out of 7. Now that we have our base model that can just barely make generalizations, it's time for an upgrade. We need more data. The problem is, Twitter doesn't have a free API anymore. Ever since Elon Musk bought the company and attempted to rebrand it as X, he has aggressively fought to prevent scraping. Twitter's few remaining employees have tried many methods to make it as difficult as possible to scrape their platform. As a result, lots of APIs intended for scraping are outdated. We still need more data. How do we acquire it? Naturally, we just build a scraper anyways. I finally located an API that worked called Twikit. After downgrading my Python version and every module I had installed thus far, we were in business. The scraper utilized 5 burner Twitter accounts, with each account needing to be replaced as they were exhausted. Surprisingly, the most strenuous part of this task was creating all the accounts. These days, CAPTCHAs are ridiculous, in an uphill battle against the ever-growing AI industry. Back to the scraper. Each account would be initialized to gather cookies once, and then access the service via the cookies afterwards. This is similar to how a real client, like your web browser, accesses the website. Tweets are routed through a proxy via Tor to help evade bans, and queries are spaced out at random time intervals to mimic human searches. With our scraper up and running, I performed our first scrape and gathered the data for our dataset. Then, I needed to spend the next 3.5 hours labeling the data. Now, our data needed cleaning. I created a script that would remove mentions, links, enter characters, whitespace, and missing values. As for hashtags, I chose to leave them in because Distillbird is a model that works off of context. The hashtags could offer valuable insight into the context of the tweet. Any dataset we trained our model on was cleaned this way. After cleaning our data, we had something like this. We trained our model from before on this new labeled data. Now the model was fine-tuned more towards tweets. By tweaking the learning rate on our trainer, we seemed to have eliminated any biases obtained from Reddit. Using our trainer to evaluate the model, we get these metrics. Our model has already improved quite a bit, but there is still more room for improvement. Testing our model on the same predictions as before yielded these results. This was slightly better than last time, with a 4 out of 7 success rate. I then implemented a third output into our model, neutral, because not every tweet was going to be political. To avoid any potential biases in our model, I gathered and labeled more data to ensure a perfect three-way split. The model we trained on this dataset had outstanding metrics, especially considering how little data we trained on. This model was significantly better than anything we had done thus far. Testing our model on the same predictions as before yielded these results. This was slightly better than last time, with a 5 out of 7 success rate. The model also seemed to have a better handle on neutral labels. In addition, our model generalized well on data that it hadn't seen before. With this, Polybert was complete. We needed lots of data to draw any useful conclusions. I figured 10,000 samples would be a good representative portion for a project of this size. That's when our scraper ran into some problems. To circumvent Twitter's rate limit, I ended up creating the aforementioned 5 accounts. When my script threw the rate limit exception, I would cycle to the next account using the same cursor position on the query to seamlessly gather data. After gathering thousands of tweets on various political figures, we were ready. The conclusion. What trends could we predict with this data? What kinds of things could be accomplished with this model? Let's start simple. What is the general political sentiment around key figures in today's political climate? The political sentiment surrounding Robert F. Kennedy and Kamala Harris looks like this. Both politicians seem to have a somewhat equal distribution. Now, let's look at Trump's pie chart. Immediately, you may notice something is off. There is a predominant base of conservative sentiments, likely from Trump's supporters. Compare that to the pie charts for Kamala Harris and Robert F. Kennedy, and we can make a couple of assumptions about our model. RFK and Harris have a predominantly neutral base, which seems pretty different from Trump's conservative majority. Outside of the explanation that these are his supporters, this does seem strange. It is likely that our model has a bias towards any tweet containing the words Trump, and is likely to label that tweet as conservative. This is due to the large amount of data we trained the model on that contained the word in conservative context. What about change over time? These two graphs show the percentage of each sentiment month by month for Trump and Kamala. Kamala's steady increase of conservative sentiments is likely because, as the election grew sooner, conservatives got more fired up about their opponent. This is further evidenced by the peak of conservative activity happening in September, a month before the election. Now, let's take a look at RFK's graph. Here, you can see a peak in conservative activity in September, before a sharp decline. This lines up perfectly with RFK's decision to endorse Trump, which happened in late August. The conservatives that were harassing him to drop from the race stopped, while the liberals tweeted about him more out of anger. This idea of events causing shifts in political sentiment is intriguing and can be expanded upon. What other events can we analyze? This graph shows the difference in sentiment percentages before and after some major event. Specifically, in this case, when Biden stepped down from the 2024 presidential race. With neutral tweets going down and political tweets up, it would seem that this event caused the sentiment surrounding Joe Biden to become more politically charged overall. Here's an event comparison graph for Trump's conviction. Neutral tweets went up as news coverage exploded, and liberal tweets also went up, as the other side celebrated the conviction. Here is my personal favorite, the event comparison for when Hillary Clinton said, "Pokemon go to the polls" in 2016. Though you might not expect it, this action seems to have slightly turned the odds in her favor, with liberal sentiment up and conservative sentiment down. I'll be closing this video with some other ideas we can apply this thinking to. With better training and dataset collection, this model could easily be made more robust and be of more use. One day, we might revisit this topic. We might apply it to new problems. We may expand the model and get better data. For now, this will be it. Thanks for watching my short video essay.